All right, so here we have our ball balancing beam buggy. As you can see, there's an acrylic beam here that was all laser cut from acrylic. This is the cart that we have that is going to be controlling the angle of the beam. It has two ball bearings in here to provide weight so that it can balance the weight of the ball. The ball has an electrical tape on it temporarily until a 3D printed part can be used. This provides extra friction and slows down the ball's movement to make it controllable. On the back of this motor here is a Hall effect encoder. The motor is a 100:1 ratio geared DC motor, brushed. We're detecting the position of the ball using a soft pot, which is a resistive potentiometer that is force sensitive. In order to detect the angle of the beam, we're using another encoder here, which is an optical encoder, and it's coupled to the beam in order to detect the rotation. In order to calibrate the system, we have these stands that hold the beam at a 0-degree orientation. This is necessary because the encoder that does the beam's angle is not absolute. It's a quadrature encoder, so it needs to be calibrated at a null position. Additionally, the ball is set up to be close to its desired position in order to help to eliminate the jumps of the cart during initial startup. Over here is the controllers for the design. It has sensor interfacing for both of the encoders and also for the strip. The strip is analog input and it has a low pass filter. There's also an Arduino motor drive shield from Adafruit and an Arduino Due that power the design. In order to start up the design, we first turn on the power for the cart and also the encoder. This eliminates the jumps in position that the encoder would have if the power was applied before the Arduino was powered on. Next, we will connect the power to the Arduino in order to begin the control, and we will begin collecting serial data. Finally, we will plug in the Arduino to the DC motor and it will begin to control position. As you can see, it is controlling the position of the ball, and we will remove these stands, and as you can see, it is balancing the beam with the ball on it. If you disturb the beam, the cart will maintain the balance and keep the ball in its position. You can also disturb the ball outside of its desired range. The cart will move until the ball is once again in the range, and then once again maintain balance of the beam. That's good.